Welcome friends, welcome to iLitmus Study Chemistry Online. Today we are going to start 10th Standard Chemistry NCERT pattern. So let's look into your chapters. First one is chemical reactions and equations, then acid, bases and salt, metals and non-metals. Fourth one is carbon and its compound. Fifth one is periodic classification of elements. So now you see from 10th standard onwards, it's a foundation for making you which will lead towards advanced chemistry. Yeah. So these are very important chapters to build up your chemistry knowledge. So let's start today with our first chapter, chemical reactions and equations. So what are the topics under this chapter? Chemical equations. So we'll try to understand how to write a chemical reaction, then how to balance a chemical reaction. What are the different kind of chemical reactions? Combination reaction, decomposition reaction, displacement reaction, double displacement, and what is oxidation and reduction reactions. Then we'll try to understand effects of oxidation in daily life as corrosion and rancidity. Rancidity is like foulness, something which smells very bad. Yeah. So let's move forward. So first, chemical equations. If you'll see, if someone of you have gone into a chemical laboratory, then you can see you do a lot of reaction into this. Putting something into your beaker and mixing some another thing, and the color changes, or some gas comes out of that because of some reaction, or entirely some precipitation happens into that beaker. Yeah. So a process in which one or more substances, which we call as reactants, are converted to one or more different substances, okay, which we call as product in the chemical equation. So left side, what will be present, that will be your reactants. Right side we present all those which is a product. Substances are either chemical elements or compound. Okay, so you can mix two different elements and can become a compound, or you can have a element plus compound making another compound. Yeah. Or sometimes decomposition reactions, which we'll understand later, in which a compound converts into elements. So it rearranges the constant atoms of the reactant to create different substances as product. Okay, this is very important to understand. Actually, the atoms doesn't destroy. Atoms of the different reactants, yeah, they come out from their existing compound and form another bonding with another atoms. Okay, so for example, hydrogen and oxygen mixes and makes H2O. Okay, so hydrogen bonds with oxygen and become H2O. Yeah. Similarly, calcium oxide mixed with hydrogen H2O and makes calcium hydroxide. So what happens? Calcium and OH ions make different bonding, okay, and create a different product. So it's actually a reconstitution of bonding between different atoms. So as a part of your chemical reaction, what happens? It can change state. So sometimes, like if you mix two different liquids, but something will become precipitate. Yeah. So color can be changed. There can be some evolution of gases, maybe change in temperature also. Yeah. How to write a chemical equation. Yeah. To explain the chemical reaction phenomena in words. What do you mean by that? Like just now in this back we saw that something happening here, some chemical reaction happening here. Yeah. So it's a big physical phenomena. We are able to see that in something in already beaker, you are mixing some from another beaker. So how to put this complete chemical reaction phenomena into words? Yeah. That is what we call writing a chemical equation. So what is presenting, that if magnesium will be exposed to oxygen, it will make magnesium oxide. Okay, but you can see here just I have mentioned the element and the compound and the reactant. Left side is called reactants, right side it is called product, which is magnesium oxide. Yeah? This is a skeletal chemical equation, means only the formula has been written. Okay, it's not balanced. Like you can see left side there are 2 oxygen atoms, but right side there is only 1. Okay, but the formula of these components are in full. Okay, you cannot have a different. If you write Mg2O, there may not be such kind of compound existence. Yeah, so you cannot write anything. You must know the what is the constituents of the compounds. Okay, so this is called a skeletal chemical equation. What is called balanced chemical equation? So write the skeletal chemical equation. Say for example Fe plus H2O is making Fe3O4 plus H2. Again this is not balanced. You can see left side there is only 1 oxygen, but right side there is 4 oxygen. Okay, so but we know that in any chemical reaction there is, you cannot destroy the atoms. Okay, so the total mass of reactants must be equal to total mass of the product. Okay, so you need to balance this equation. So how we do that? Select the element with highest number of atoms, either reactant side or product side. You select the atom which has maximum number. Okay, so in the above reaction you can see oxygen right side in Fe3O4 is the maximum, 4 atoms. Okay, so first balance it. So what you need to do, left side in H2O you multiply by 4. Okay, so what you did, you multiplied 4, then right side and left side the oxygen has been balanced now. Next what you will do, now pick other component in Fe3O4, either Fe, either H. Okay, so in LHS requires 3 Fa. I am just trying to balance with Fe. So right side you can see there are 3, so left side you need to have 3. Okay, if I'll go by H2, then what I'll do, left side it is 8, right side it is H2 only 2, so right side I will multiply by 4. Okay, see this I do, so I am doing by Fe. So left side in this Fe I multiplied by 3. Okay, so what happened, 3 plus 4 H2O equal to Fe3O4 H2. Now still it's not balanced. Right side only 2 hydrogen, left side 8 hydrogen. So I'll just multiply here by more 4. Okay, so that will become 8 hydrogen now. So now this is balanced. No any extraordinary method, just employ this method to any of the skeletal chemical equation and you can balance it. Try today with in your exams you can expect questions on this one. To make a chemical reaction more informative, the state of reactants and product is required. Okay, so I am mentioning here, this is solid, this is gas, this is solid, this is gas. Okay, so I have mentioned the what is the state of these reactants and products. To make it more informative, okay, the next one is what is the temperature, because every reaction happens in a particular temperature, pressure. Some reaction requires some kind of catalyst. Okay, so to infer complete information you mention like this. So here you states mention for product and reactants. On the arrow up you mention 340 atmosphere, you can mention the temperature, you can mention the catalyst. This is writing a full balanced chemical equations. Then going forward, type of chemical reactions. No change in element of participating reactants. This is very important. Okay, what will happen? No change in the element. When I say, it doesn't mean that element doesn't go to compound. It goes to compound, but it's there. Atoms don't disappear. Okay, it's always available. It involves breaking and making of new bonds. Type of bonds we'll understand in our 3rd and 4th chapter. So let's first understand what is called combination reaction. 2 or more reactants form to make a single product. Example, calcium oxide and water when you like put your calcium oxide, you buy from market, which is called as limestone, you put into water, you will see a lot of reaction happening. Some bubbles will be coming out, and the bucket in which you will be putting this water and calcium oxide, it become a bit heated. Okay, so what happens in this reaction, this both two different compounds, calcium oxide, which called limestone, and water mixes and makes a calcium hydroxide. Okay, so two different reactants make a single product, then this is called combination reaction. Generally these are sometimes exothermic reactions, because what is called exothermic, when reactants form product and heat, some heat is get evolved in this reaction, that is called exothermic reactions. Endothermic, where reactants require heat to form the product. Okay. So explain what whitewashing of walls. What is whitewash? What we do? We mix the limestone plus water in the bucket, and we just make our walls. This whitewashing is done. But at the time, you cannot see the shining wall. It is just like water kind of stuff and little bit whiteness. But after 2 days, 3 days, it becomes solid white. What happens? If you can see the state, this calcium carbonate, that is solid and this is liquid. So once this liquid part of the product get evaporated, after then once the calcium carbonate, which is the color of white, comes brightly. Okay, after 1 day, 2 days. So what is combination reaction? Two different reactants like calcium and sulfur mixes and make a single product, which is called say calcium sulfide. So combination reaction, I hope it's clear. Then coming to decomposition reaction. Okay, what happens? A single product, you can see water, has been converted into two different products, which is called hydrogen and oxygen. Okay, that is called decomposition. So one compound breaks into multiple compounds, or mix compound plus element, or elements plus element. Here like element plus element is coming. So that is called decomposition reaction. Single reactant breaks into two or more simpler elements or compound. Okay, generally decomposition reaction requires energy. Yeah, so these are mostly endothermic reactions. Example, 2AgCl solid converts into 2Ag plus Cl2 gas under sunlight. So if you put silver chloride into sunlight, then all the silver get precipitated on the bottom and chlorine comes out as a gas. Then what is displacement reaction? Understand this. So a reactant A is reacts with BC. BC is one compound. Then B element of BC comes out and joins with C. Okay, C component joins with A. So AC and B has become. Okay, so what is displacing? A is displacing B from BC as a compound. Let's understand in a very different way. Okay, so zinc reacts with hydrogen sulfide. So what happens? Zinc displaced hydrogen and makes zinc sulfide and hydrogen sulfide. Okay. This looks something wrong here. Yeah, it should be hydrogen coming out. Something wrong here. Yeah, apology for that. Note, reactant A must be more competitive, more reactive component to B. A यदि ज़्यादा reactive नहीं है C के against, okay, B के comparison में, then it cannot form AC. Okay, BC ही रह जाएगा फिर. ठीक है, तो A होना चाहिए, A के bonding C से ज़्यादा strong होना चाहिए बजाय BC के. Okay, let's understand this format. Okay, what's happening here? A old guy having his old madam wife, he is more, and here there is a girl, young girl, so there is a high chance of displacement here. Okay, so this old man has got this lady. Yeah, so this lady here is more reactive. Okay, so she is able to displace this old woman. Yeah. Now understand this case. What happening here? You can see this is one couple, this is another couple. They meet into a party and it's swapped. This girl gone with this guy, this girl gone with this guy. Okay, so this party becomes like a catalyst. Yeah, and you can see swapping completely. This is called double displacement reaction. Okay, example, AgNO3 plus NaCl. So what it forms? Ag when meets with Cl, it's a high prone to become precipitate. Okay, so AgCl and NO3 is formed. Then oxidation and reduction. These are very important chapters going forward. Yeah. So if a substance gains oxygen, then it is called oxidized. Similarly, if a substance loses oxygen, then it is called reduced. Okay. So oxidation and reduction happen in a single reaction. Something loses oxygen, something gets oxygen. Okay. So take this example. FeTO3 plus 3 carbon monoxide, then it gives you element Fe and carbon dioxide. So what happens here? Another way of saying this one. Okay, let's see this. Here, this is getting more oxygen, right? Means some kind of oxidation is happening. This is losing oxidation, means some reduction is happening. Okay, let's understand in a different way, which will be more important going forward. This is electron donor. It has some electron which you can donate to other. Okay, so once here, like for example Fe3 plus, it has some it can take some electrons, right? So you can see Fe3 plus to Fe means he has taken 3 electrons. Okay, so this is called reduction, means gaining. Okay, gaining of electron is reduction. Here you can see it is gaining electron from this one and getting one electron. So getting electron is reduction and giving electron is oxidation. So you can see he's giving electron. Okay, how? First it was C2 plus, after then it become C4 plus, means it has given 2 extra electrons. Carbon is given 2 extra electrons. Okay, this is very, very important. Going forward, you'll be having a lot of questions. This is used to calculate in your, when you'll be understanding equivalence, then these are required. Yeah, it's a very important concept. Then coming to effects of oxidation in daily life. First one is corrosion. When a metal is exposed to water or moisture or some acid, then you can see that how this, say your AC is kept outside of your house due to rain or some moisture. Yeah, the nuts, first they start with not getting corroded, then whole body starts getting corroding. Yeah, so you can see this picture, how this corrosion happening to the dented spots. How this paint helps you to avoid corrosion. When the paint is there, then moisture or water doesn't comes into contact of the iron in the car body, and it avoids any kind of oxidation. So corrosion, paint avoids corrosion. Okay, similarly you can see here how this nut has been corroded. We spray oil on spanners or other tools. Generally if you'll see some tools, on that we spray some oil, okay, some grease. So what happens when grease or something is there, then water or moisture doesn't come into contact of the tool metal, and it avoids corrosion of the tools. Then what is called rancidity. Rancidity means foulness. Yeah, so when fats or oils in the food are oxidized, they become rancid. It smells foul. Yeah, smell and taste changes. Why? So you understand that inside that food there is some oil or something that is oxidized, and becomes foul. So why something kept into tight jar doesn't smell foul quickly? Because oxygen will be not coming into that contact of that food. Similarly, if you'll see your typical chips packets, why it's always fluffy? You always feel some kind of like air into that. Okay, it's a special air which avoids any kind of like oxidation. Okay, so this is all into this your chapter. Thank you very much. Thank you for watching this video. You can go to watch our next video for 10th chapter. You also know that we have already launched the video for chemistry for 9th standard. Thank you very much.